Thank you.
Shall we
Ma'am?
start, sir?
Yes, ma'am. Yes, ma'am.
Okay,
Right,
ma'am.
right, sir. We are very close to 7:30 p.m. Even in
Okay.
this dark hour, our participants are fully energified. They are awaiting your energified session now, sir. It's my pleasure to introduce our esteemed resource person, Mr. Mukesh Mariappan, an accomplished process engineer with over a decade of experience in machining, machine assembly, and digital manufacturing. He holds an MTech in digital manufacturing from BITS Pilani and has worked extensively on new product development, process automation, and Industry 4.0 innovations. Currently, he is a senior engineer at Lucas TVS Chennai, where he specializes in process planning, capital investment projects, and the integration of smart manufacturing technologies. Mr. Mukesh Mariappan will share his insights on the manufacturing process of lithium ion batteries, a crucial component in modern energy storage and electric vehicle technology. Let us welcome Mr. Mukesh Mariappan for an engaging and informative session. Please, sir.
Thank you, ma'am. Thank you.
Welcome, sir.
I hope my screen is visible, ma'am.
Yes, sir.
Yeah, visible, sir. Yes, sir.
First of all, I would like to thank to everyone for this wonderful good evening. And myself, Mukesh, already Madam told regarding my introduction. I start my career in 2013. Last 11 years, I have a working experience in automobile industries. And I start my career in Rana Engine World Limited. Their engine world manufacturing. That it is a powertrain component. And after that, I went to Dura Walls India Private Limited at Aurangabad. There also they are manufacturing engine walls. After that, I went to one Japanese company. It is an Indonesian Private Limited. There also they manufacturing engine walls. So I have a little bit of knowledge of engine internal combustion engine. So that is the reason I could know about what are the upcoming trending technologies that I want to know. So that only I meet Mr. Venkatesh sir regarding that one only. So he only give this opportunity to deliver that one. So I could thank to Mr. Venkatesh sir also.
Thank you, sir. Thank you, sir.
After that, today I will little bit of explanation about the types of fuel cells and the types of batteries and the manufacturing process of a lithium-ion battery. This I plan to explain that one. Shall I start, sir?
Yes, sir. Start, sir. Thank
Okay.
you.
The classification of the fuel cells, it is two um, types are based on electrolytes and fuel and oxides. This is the two category. Alkaline fuel cells and the phosphorus acid fuel cells and proto exchange neutron fuel cells and molten carbonate fuel cells and solid oxide fuel cells. This is the electrolyte based fuel cell category. And fuels and oxides, hydrogen pure and oxygen pure, it is a one time category of fuel cells. And hydrogen, it is little bit like richer in gas and the air, that is a one kind of fuel cell composition. And the ammonium and ammonium air fuel cells, synthetic gas and air fuel cells, and hydrogen gas and air and fuel cells. These are the major classification in uh, fuel cells. And first, all of them are very well aware about that alkaline fuel cells. It is the first fuel cells technology developed uh, in the world. It is the first time widely used in US space program to produce the electricity energy through water on that spacecraft. This is the simple definition of that alkaline fuel cells. And phosphoric acid fuel cells use liquid phosphorus acid as a electrolytes. It contains Teflon bond silicon carbide and porous carbon electrodes contain platinum catalyst that electrochemical reaction that takes place in the cells. It is shown in the diagram. It is the first generation fuel cells for the modern fuel cells. It is one of that fuel cells. Initially, they are used for commercial vehicles and power generations and large vehicles also. And this is that very major thing, proto exchange neuron fuel cells. Here, electrode as a anode and cathode. It is separated by the polymer membrane electrolyte. Each of that electrode on one side with a thin platinum catalyst layer. That electrode and catalyst membrane from the membrane electrode assembly, electrons or air supplied on the either side through the channel. It will produce that energy. That advanced stage of that proto membrane fuel cells. Department of Energy, they are planned to the target for alternative source. So that is the reason they are developing this one. And the solid state fuel cells. Currently, mostly they are planned to using for high energy power production. They are using and they are starting for solid state fuel cells. And this is that major fuel cells. Now I will start that battery. In that, now only we are talking about the battery. In the initial stage onwards, we are using that battery on the 12-volt batteries. Mostly for in any vehicle, we will use for 12-volt and 24-volt batteries for power distributions and the engine startup process for IC engine majorly. Nowadays, that 28-volt and the 24-volt are used in the IC engine components and some hybrid vehicles like plug-in battery, electrical vehicles, that regenerative braking systems and torque booster, power to drive electrical drives. That nowadays mostly for EV vehicles.
Sir.
Okay, sir. Yes, sir. So mic mute X. Yes, sir.
And nowadays, for the EV vehicles and the hybrid vehicles, they will use for they are using 400 to 800 volt batteries for drive the electrical motor. And in that EV vehicles, the BMS, the battery management system, it is a very vital role to manage that
Yes, sir.
battery life
Sir, a screen not, sir. It's a screen. Yeah.
Oh, sorry, sir.
Okay,
Sorry,
yeah. Thanks.
sorry, sir. Sir, now it is visible.
Visible, sir. Yes, sir.
Yes, sir.
Okay, thank you, sir. And battery management system, it is a very vital role in EV, and that only it you managing the optimization of the performance of the battery cells and protect that battery. This is the major important role of battery management system. The types of battery, the lithium ion battery, currently most of the people in automobile industries, they are using the lithium ion battery only. And the solid state battery in China, already they are used the lithium ion battery. Currently, they are developing the solid state battery, because compared to the lithium ion battery, the solid state battery, it is a very high performance, and that weight also little bit reduced, and that fire flammable. Compared to that, the solid state battery, it is very low hazardous, and it will not flame not very easily. So they are preferring for develop the solid state battery. And the next one is it is a lead acid battery. In the railway station on the Gulf ground, they will use one that battery vehicle, and that they are using the lead acid battery. The nickel, that one is very rarely they are using. The solid ion, that battery, currently they are using plan to stock that one. The zinc ion, it is a very high in performance, and the cost also it is very low. The lifespan, it is very moderate, that mostly they are not using. So now we are started how they are manufacturing that lithium ion battery process. Before that, a little bit explanation of about lithium ion battery. In the lithium ion battery, electrode, anode, and electrolyte, and one separator. These are the major component in the battery. What it will happen means, the type, it is a rechargeable type lithium ion battery, that the anode to cathode during from anode to cathode, it will move during the discharging, and back it will come to while on charging. The primary function of the separator is prevent direct physical contact between the anode and the cathode, while allowing the lithium ion to pass through. The separator is a flame. It mostly commonly made of the polymer. It must be a mechanical strength to withstand the winding operation during the battery assembly. The another important testing during the battery cell production, the electrolyte leakage, it may be flammable and explosive. That is due to that the separator is a play a vital role. It is the outer structure. Mostly, if any, all EVs, one onboard charger is there, one battery system, and the battery backup, one DC converter, and a thermal cooling system, and one electrical motor, and power electronic controller is there. Mostly, there is the outline of that one. Same in that onboard charging, one power electronic system and controller will be there. Power pack, in the power pack, a module. In that module, one cell is there, and one BMS control is there. The total overall setup is the battery back setup. The battery back setup is linked with the two DC converter, and one power drive unit is there. It is like a motor, DC to AC converter, and controller, and the power electronic system is there. And to produce from motor, it will drive. We can able to drive the car. Now we will start the that first initially I will explain that one. In the lithium ion battery, totally 3 major steps is there. One is module assembly and the battery backup assembly and top cover assembly. These are the major assembly they are following in lithium ion process. First, in the module assembly, what they will do, I will explain that one. First, they will shorten that cells based on that ranging of that voltage. They will separate that battery cells. If, for example, they are giving some value 3.5 to 3.6, they are giving you a value. First, initially, they will segregate 3.5 to 3.51, one kind of battery set they will follow. Like that, they will shorten the battery and they will clean that battery and paste that thyristor on that battery, and that welding they will do, and the testing they will do. This is the major process followed in that module assembly. And next it will come to battery backup assembly. It is a individual cells. It will be connected in parallel or series connection. Several module. It will connected in a single pack in the different layer. That is a battery backup assembly. The top cover assembly. The top cover assembly, it is consists of the BMS and the positive and negative cables and all those things. It will on the top cover of the battery. This is 3 major parts in that battery manufacturing process. State of testing: cell level testing, model testing, pack level testing. In the cell level testing, they will shorten that cell based on that voltage measurement and the life cycle of that cell, internal resistance and the power and the energy capacity and efficiency. This is the level of testing in cell. And next, the module level testing, that IC internal resistance testing, isolation resistance, and the DC internal resistance. These DC internal resistance and the voltage and the temperature measurement, and they will test on that module level testing. And next, backup battery back level. Battery back level, they will check all those function of that the BMS system and the safety regulation and the performance of the battery through charging and discharging, and the internal resistance and the number of cycles it will run. That they checked in the battery level testing. It is a cell, and it is they are arranged in the parallel series. This is that module. Minimum approximately 80 to 96 cells they will arrange for based on the capacity of that battery. They will arrange that one. It is a module assembly, and it is a packed totally. Battery testing in a various stage. Before I told, in the cell level, it is a compound level. Battery level is a subsystem level, and total in powertrain. In the main powertrain, it is a system level. Drive and environment means it is a vehicle level. It is the module assembly. First, they will place that insert and bottom insert holder. It is the arrangement. It is the first step of that module assembly. After that, they will check the cell. Open circuit voltage test they will do. In the open circuit voltage, they will segregate that cell in the different voltage. Suppose we are giving that range of 3.5 to 3.6 voltage, means every 0.01 volt they will segregate. It is a one set of battery they will use, because if any huge variation they are observed in that battery, means that huge variation it will move to that battery backup, means definitely it will not perform well. So that initially onwards they will shorten that cells. This is the major testing. And the next, the internal resistance also checked in that cells. This is the next one. After that, the thyristor they will paste on that cell and properly routing on that each cell, because a thyristor measure the temperature of the cell. It will give feedback to the our BMS system. So thyristor play a very important role. So it will connect to that each cell. Then only while charging how much temperature it is rising, while discharging how much temperature it is rising. So it will give the feedback to our BMS system, and based on that, that cooling process, all those things it will be happen. And if some fuses we will use, suppose if any more heat, if they feel, means they will cut off and protect the battery and avoid that accidents. So thyristor play a vital role in that module assembly. And the next, already I told bottom cell holder and single insert, and the next one is top cell holder to support that cell on both sides. So they are using that one. And the polarity and the insert inspection, that arranging the cell in the top and the bottom holder, they will inspect the positive and the negative terminal, and that correct position or not, they will check that one. The bottom to cell holder, it will be tightened properly as per the required torque value. And the next, top interconnect load they will use to top interconnect is the join the module to one another to ensure work together as a unit. The battery module is connected like a busbar system. So after that, they will use that plasma cleaning of the cell, because the plasma cleaning is very effective to remove that organic content from that cell surface. It is if any foreign particles in that cell, means it may affect that welding process, and it will lead to some failures. So they will use that plasma cleaning process. And that interconnect already we will do that welding process on the top and bottom. Minimum 4 kg load it should be withstand. Then only that interconnect welding it is properly. It provide strong and reliable electrical conductivity connection between individual cells within the module, minimize the contact resistance, and ensuring effective current flow while being the fast, precise, and automatic process, and suitable for the high volume productions. The welding, resistance welding, they will use for this module assembly process. And after that, once that welding it is completed on the top and the bottom, that module assembly it is totally completed. Module assembly it is completed. After that module assembly completed, means that the end of line testing. The end of line testing it is a capacity testing of that cell module. If any leakage it is happening, that they will check. If any short circuit it is there, means they will check. And the major test it was carried out in that module process. Mostly this is that this module assembly almost it is completed. Only majorly the top holder, cell shortening and cell assembly, bottom holder, and thyristor pasting. After thyristor pasting, they will as per the polarity they will check that cells, the positive and the negative, and that interconnect in top and bottom of the cells, they will do the plasma cleaning process. And the next one is the welding process. This is the major process in the module assembly. Next, that battery pack assembly. Once that module assembly is completed, they will move the module to battery pack assembly. Here the battery pack assembly, before that they will do the top cover assembly. In the top cover assembly is the major important component in the battery pack, because it only having that all kinds of communications cables and that positive and negative terminal of that battery, all those things it will connected in the top cover. Initially, that module and the damper assembly, the damper they are using for the isolation purpose. It should not contact with our cover material, so they are using for damper on the bottom of that module. And right side top cell, they will fix in that module pack. It should be, while packing on that module, it should be free from any shorts. That we should ensure that one. And that right side top shell, it have a double pin for proper orientation of locking. And they are applying a sealant on that top cell for tightening that back. Similar like LH side also, top cell, they will load manually and lock that one. Already we paste that sealant also, and it tighten with double pin, and we should tighten as per that design tightening torque. And here the top cover assembly. The top cover assembly, I will explain what are the component they are that it should involving in that top cover assembly. I will explain later. And the next they will assemble that top cover assembly, and the cord set assembly, and one gasket. Sorry. First in the top cover assembly, it have that BMS and one cord set clamp in the top cover, and thermal pad pasting on the top cover, and that BMS should tight on that top cover. Cord set assembly. In the cord set assembly, having positive module cord set and one BMS communication cord set, it should tighten that top cover. In the top cover, we have one more child pot, the gasket and the isolation table, and the RTV sealant they are using for a better closing of that one. Assemble that top cover, and that bottom cover gasket. Just rotate that pot, they will assemble the bottom cover, and tighten that bottom cover screw. And protection circuit board, it is the one of that major major part in the lithium ion battery. It will protect that battery from overcharging and over discharging and short circuit. The board monitor the battery level of charging and the temperature and the signal. Once it will reach the limit, it will give that indication to the BMS system, and to safeguard that battery, and to tighten and next that tighten that BMS board. In the isolation gasket and a fuse tightening, here a BCP fixing and one fuse is there. The fuse inside, it will connect with that production circuit board. Before assemble that fuse, they will check that conductivity of the fuse. This is the major that one. Suppose initially If that fuse is not working, means the total system it may lose to failure. That's the reason before assemble they will check that fuse, and the top cover assembly tighten the positive cable to the fuse and the negative cable and communication cable of BMS and connector plug, and the sealant dispensing and screw tightening. Total overall the top cover assembly is completed, means the one silicon sealant they will use on that top cover, and also check that BMS connector cable and that thyristor connector presence. After that only they will tighten the top cover. Once that sealant process it is completed, they will move to that leak test process. Here two port is there, one PVR port and the PCM port. They will block that PVR and the PCM port. Once as per our leakage standard, we will fill that air for particular time. It should be withstand for particular time. Then only is there any that allowable leakage only. It is permission leakage. It is allowable. If it is more than the specification, means they will reject that part. They will do that rework. After that leakage leak testing process, initially that that BMS chip it don't have any programming. Once that leak test is completed, they will upload that program through CAN protocol, and they check that GUI testing. Once we will upload that our program, means we should check it is working or not, that we should ensure. After that only they will move to next process. After that, due to that they will check that voltage conductivity checking, and checking that battery cell connection in the BMS and the verification track. Before once the leak test is completed, they will check that component weight. They will check that weight. They will fill that PCM phase change material. This is the one of that important thing, because the PCM material it is like wax type of material. Why they are using, means suppose it is a wax type material. In initially 60-degree temperature, we will heat that one. We will go to that the battery pack. Yeah, it will fill our cells. What will happen means, while charging and discharging, that cells will be heated. Due to that wax material, it will be from solid state to it will move come to liquid state in charging and discharging. When it is a normal condition, it will again it will go and set as it is a normal condition. So it is a very important thing. So they will, before battery pack weight, they will check. After applying a PCM, they will check that weight. And the PCM consider a composite material of paraffin wax and graphite additive. A graphite, it is typically added to improve the thermal conductivity, and a pure paraffin wax, it effectively to maintain the temperature, observing and releasing the heat during a phase transition. After once it is completed, lock that port. While pouring that PCM, it is a 60-degree temperature, so they will cooling for a particular time. Then only the process it will be completed. Once all the process it is completed, means they will check that vibration testing. Why it is required means, mostly now we are using in assembly process environment, so there is no it is a very smooth and condition. We will handle our battery very good manner. But in the vehicle condition, based on our road capacity, while running, definitely it will be some vibration. It will be happen. So that vibration test it is a very mandatory one, and so we will do that vibration test for battery pack. We will check if any loose connection is there, means we can able to uh, uh, detect that one while charging and discharging during the vibration. If any short circuit maybe happen, means we can able to reject that part, and they ensure the battery pack functional failure. If any happen, means we can able to detect that one. And once that vibration testing it is completed, means that end of line testing. The end of line testing, as it is similar like uh, throughout how in live one battery will function, like that only we will measure all those things. Once we will connect the corset cable, we will check that current, temperature and voltage while charging and discharging. This is the major thing. It will nearly we will conduct for minimum half an hour to 1 hour. Then only we can able to understand that battery capacity, that all cells are filling properly or not. We can able to simulate that one. That is possible. It is the end of line testing. So it is a very mandatory test. After that only we will move that part to that final inspection. Here mostly module assembly and top cover assembly and battery pack assembly, the process it is completed. But here one important role for a BMS system. Why that BMS it is required? A BMS system, it will be differ from different voltage. In that initially 12 volt, it is we are using. It is a single battery, and nowadays 48 volt we are using. How much output means 5 to 15 kilovolt only we will get. So that if any incidents it is happening, means we should protect that our car and our vehicle. So that battery management system, it is a play a minor role in that driver information system. It is available in our vehicle, so it will give some alarm. Our battery is drained, our battery is overheating, like that it will give. Nowadays, battery is a major part in EV vehicle. So the battery management system, it is a play a vital role in that. So in all cars, they have a front end driver information system. So it will give from battery management system, it will give the communication, how much battery percentage it is there, how much temperature is there, how much, that all information it will give through the battery management system. Typically, battery management system block diagram, each individual cells it will connect with cell monitoring and balancer, and one temperature sensor is there, one ECU is there. If any fail happen, means it will automatically it will communicate to the BMS system, and one current sensing unit is there, and the current sensing unit it will connect with our fuse, and solid state one switch will be there. It will be connected with battery pack. If any low supply is coming, means it will give the information. If more temperature or more heat will be there, means it will give some indication to all. And next one is cell balancing. It is also the part of that battery management system, that all cells it will not function equally. Each cell has each capacity. some cells it will filling easily quickly charging, and some cells have very easily drain. So we should monitor all those things. Which cell which cell it is a very weak condition. That cell, sorry, it will indicate that cell capacity and which cell it is drained very fastly, that we can able to detect. That is possible in through BMS system. This is the major process in lithium ion manufacturing process. So if you have any doubt in lithium ion manufacturing process, you can able to ask that one.
Participants are requested to ask any, if you have any clarification, please ask.
Yes, sir. Yes, sir. Sir, recently I heard news the Ola is firing battery like that. We're receiving a lot of messages like that. So I may know the reason, sir. What is the reason this fire is square in Ola?
Sir, the two things is there, sir. One is mostly the Ola. Why it is failure means that is due to purely the electrical motor. The electrical motor, that winding, it is too much issues. It is not relevant to that battery system.
Okay.
Mostly 50% of the problem due to that electrical motor side only. So two things is there, sir. That the motor play a vital role, and the EV battery also play a vital role. Mostly that all EV battery manufacturer, they are very much taking care of battery system, because it is a very easily flammable, sir. If they put any manufacturing plant, means our government they give some more restriction how you should control the flame, how your battery should control if any accident it is happening, means how it will be, how it will be safe. Our ARIA also, once I am a battery manufacturer, means they will check first how much safety this battery. After that only they will given for that they will give that start the manufacturing production, sir. So mostly according to my point of view, because my colleague is in he is in Mali, so sorry. They are the motor manufacturing process for the Ola. So in that winding process, they have some issues, some imbalancing in the motor. Due to that reason only, it is overheating and easily flaming. That is the reason, sir.
Okay, nice, sir. Thanks, sir. Thank you.
Sir, I have one query, sir. Is there any replacement for lithium-ion battery, sir, due to its lack of availability in Earth?
Mostly now our government is supporting for the battery swiping system, madam. Currently, we are using that. Currently, we don't have, but in the future, mostly our government initiated for the battery swiping system. So we can able to replace which cell it is weak, that we can able to replace that one, ma'am. That is possible.
Yes, sir. Thank you, sir.
Thank you.
Now it's a chance for participants. Dear faculty participants, please share your views, as well as if you have any queries, please ask.
Sir, good evening, sir. Sir, is there any technique we can integrate into it for earlier prediction of firing techniques, sir?
Earlier production of firing techniques. Sir, mostly they will measure the temperature while charging and discharging, sir. So can you repeat that question, sir, please?
Sir, I want to know whether is there any techniques for predicting the fire catching earlier itself? Can we detect it earlier itself?
Sir, now the most of that battery backup system, it will give that it have that fuse. Suppose if any abnormality observed by that BMS system, automatically it will power off that battery, sir. So we can able to protect that our vehicle. So BMS, how it will catch that the temperature means already in our cell we are pasting the thyristor. The thyristor give that information to each cell temperature. If any abnormality it will found means automatically the fuse will be cut off that overall battery. So our vehicle will be safe.
So
I
nice
have only
answer.
one clarification regarding student welfare, sir. If any student want to get placed in the EV related companies, what type of skills they expected to acquire?
Madam, mostly MATLAB, one thing, ma'am.
Yes, sir.
MATLAB, and
Yes.
there is too many because that it is our engineering department. Too many simulation. Too they are well versed in simulation process of the battery. They can able to place that one, madam. I will show one presentation. It is
Is there any specific certification course for networking Cisco is recommended? Like that for EV, is there any particularized certification courses available, sir?
definitely is there, ma'am. I will text to Mr. Vendesh, maybe today
I
or
will
tomorrow.
collect and share it with our students, sir. That's what.
Oh,
Thank you, sir.
okay, okay. Definitely, I will share that, madam.
Yes, sir. Thank you, sir.
Okay, sir. Yes, sir.
Sir, I
I
have found that. Sir, I found that during travel only the EV vehicles usually catch fire, sir. Is there any techniques for making it to maintain the temperature or keeping the battery in a
Yes, sir. Yes, sir. In
coolest
that
manner?
all the for four-wheelers, we have thermal cooling system. It is available, sir.
Okay, sir.
1 minute, sir.
Okay, sir. Okay, sir.
Here, na, sir. Mostly the thermal cooling system is there. That during the thermal cooling system, automatically it will cooling that battery pack temperature, and inside I told na, sir, the PCM material. That PCM material, it is a wax type material. Suppose if it is overheat means it will automatically it will change into liquid condition. Due to that liquid condition, it will observe all temperature. Maximum for we can able to drive our EV vehicle for 3 to 5, 4.5 hours only. So for this much of time duration, definitely it will be withstand, sir. The thermal cooling system, it will be, sir, definitely it will be support.
Okay.
Thank you, sir. Thank you for the valuable answer, sir.
Sir, and also one more thing. Here, this is one supplier he given for battery testing and the BMS testing. I will show this one to you, sir. How much testing they are conducting for battery. For battery management system, this much that hardware in loop system, the battery cell simulations and the fault simulations and the temperature simulation, the IR isolation resistance simulation, we can able to do that one for BMS. And next for inverter, for motor simulation, sir. Motor and there's some sensor simulations. If we want to view load, that also we can able to simulate. The fault simulation we can able to do that one. The battery pack also we can able to simulate. This software which will be support to 200 cell real time value. We can able to take that reading for support active and passive balancing scenario to monitor that simulation like this. This is the application. They have developed their own application for battery simulations. That were motor simulation setups. This is a real-time application. They are used in many industries, sir, for EV motor manufacturer. While lithium-ion battery, while charging and discharging, how it is behaving, that we can able to monitor that one. That is possible. And lithium-ion battery major failure, overcharging, and battery misusage exposed to high temperature. If any manufacturing defect means it will be might be failure. Is there any short circuit means that is possible for battery failure? It is a simple architecture of a battery system. One thermal chamber and a measurement that rack. It will give the feedback to our server. We can able to take the report here. This is the outline of that. It is a live how they are checking on battery back system. This is a measurement area. Here in the cycler, they will use that load, actual load, how much it will be take while driving, how much load it will be take. We can able to give that load so manually. We can able to check how much discharging is happening within a particular time, how much charging is happening. That is everything we can able to check. That battery cell simulation. The battery all cell it will be connected with our BMS system. We can able to simulate charging and discharging and that how much energy it is producing. Which one it is a weak one? That if it is a weak one means how it will be reflect that load. Everything we can able to simulate that one. Here through simulation also we can able to measure the temperature, how much it will produce. We can able to how to stop all those things. We can able to simulate that also. Yes, sir. That's enough, sir.
Yeah, nice, sir. Very good, sir. Really, you are showing some real-time data. Thank you very much. This is industrial data. Thank you
Yes, sir.
for your sharing of this valuable input, sir. Thank you. Ma'am,
Yes, sir.
Bhunesh,
Yes,
ma'am?
sir.
Yeah.
Yes, sir. I'm here, sir.
Yes,
Yes,
ma'am.
sir. Thank you, Mukesh, sir. Really, the session is really wonderful, sir. It is very much useful for all of us. Being one of the participants, actually, this is my feedback also. Your presentation is concise and very clear, sir. It's very useful for me, for beginners, and who is willing to learn in advanced mode also. Thank you so much, sir. Thank you, sir.
Thank you. Thank you.